Are we all nice and settled, guys? Hello, I'm Ashley. I am from Linux Recruit and DevOps Exchange. So thank you all for coming out tonight. I know it's a Monday, and I know it's raining, and I know there's international trouble brewing, so thank you all for being here. Has anyone been to a DevOps Exchange event before? 1, 2, 3. Okay, quite a few, yeah. This is our third event in Manchester. We had one for International Women's Day last Thursday, and we launched late last year, so it's good that this community is growing. I'd like to see some familiar faces and some new people as well. The DevOps Exchange, in case you don't know, we are all over the country and in Barcelona. We flew past 10,000 members. I wanted to have a party, but I missed it, so I promised myself once we hit 11,000, we'd celebrate. But then, thanks to all the events we've got in March, we just hit it. So thank you so much. We are in Edinburgh, Manchester, London, Bournemouth and Barcelona, and we host events regularly every month. So moving forward, fingers crossed, there will be a Docsman for you to come to once a month. Okay, so we are live. We've got a camera there, there's a camera there, microphone. If you could all follow us on Twitter at The Docs Hub. That's kind of where you'll see all our up-to-date news, where you can watch other events live. If you're ever interested in, say, a speaker in Barcelona or a speaker in Edinburgh, that's kind of your go-to for all of our news. If you're going to take pictures tonight or share your thoughts, if you could hashtag Docsman so I can have a little nosy at them after the event, that would be great. Tonight we have a bunch of wonderful people speaking. We have Jamie from BJSS. Jamie, where are you? Who is talking about DynamoDB pricing models. We've got Rob Greenwood. Where are you, Rob? Okay, cool. Accelerating software delivery with AWS. And then we've got James Young, who is a little bit of a local celebrity in the meetup scene, I think. Yeah, people were talking about you at our last event. And I said, oh, he's going to be there on Monday. Talking about empowering developers in the cloud. All of our events locally have a head of, so your local Manchester DevOps Exchanger is Nick Tyson, who is going to come up and just give you a little bit of a insight into how the rest of the event's going to run. Okay?
Thank you. Turn on the clicker as well.
Yes.
Everything. Thank you. So a couple of things really. We're using Slido tonight. So if you go to your phone and web browser, if you go to slide.do or slido.com and enter the event name Docsman3, we're running a poll that's been going on all day, asking you how often you deploy to live a day. So we'll see people who've been around a while up there, and I'm hoping all of you youngsters and startups are down here doing hundreds a day, and we'll see how many are in different areas. You can see the results as they come in, but we're also going to, there's questions and answers in there as well. So we're going to do a panel towards the end. You can ask questions in there. And then as the speakers go through, you can ask questions of them and we'll pick them up at the end, make sure they all get taken. And you can give thumbs up if somebody's asked a question that you like as well, and you want to make sure that gets asked. And then just very quickly, hopefully, no outbreaks or anything. 23rd of April is our next event. Nigel Poulsen is going to do a 40-minute presentation. Then there'll be 2 other speakers. Steamhouse, who Rob works for, and Phil over there are sponsoring that event. So keep that one ready in your diary. That should be a really good setup. Ashley.
There you go. Thank you. So every event we have different sponsors and we have different hosts. This is the second time at Barclays Eagle Labs, so thank you so much for having us again. But all of our events are sponsored by Linux Recruit. Not here to ram recruitment down your neck, because that's not what tonight is about. Tonight is about building a DevOps community in the Northwest. But if you did want to talk to anyone about growing your team, or if you're confidentially looking for a new job, or you just want to have a chat about what's going on in the market at the moment, I do actually work for Linux Recruit as well, so do come and give me a shout at www.linuxrecruit.co.uk, have a look at our jobs, have a look at our clients, and come and pull me aside if you Fancy discussing any of it?
Okay, good evening everyone. Also just to say that this evening's event is a part of the Digital City Festival. It's the first Digital City Festival in Manchester. It's happening all this week. There is a pamphlet just outside if you'd like to learn more about the events that are going on this week. My name's Michael Fordham. I'm a cloud consultant and the platform capability lead for BGSS in Manchester. And we are proud to be the lead tech sponsor of the Digital City Festival. So if you'd like to talk to anyone about that, come and see me either throughout the event or after it. But please be aware that you're part of an inaugural event tonight, and today is the first day of the festival as well. So if you would like to share your experiences or learn more, as I say, please come and speak to me afterwards. Okay, and as I said, my name is Michael Fordham, I work for BGSS. When we came up with the theme to this event, we were trying to think about what's really relevant in the cloud right now. And I think since the inception of the cloud, 13, 14 years ago, we started to see an awful lot of work with our clients around moving applications into the cloud and all of the struggles that that would bring. And I think through the first few waves of that, we're now starting to see a bit of a sea change in the industry whereby clients are either developing applications for the cloud or even going one better and developing in the cloud. But that brings a different set of problems because people are asking, why can't I develop as quickly in the cloud as the book I read on Netflix told me I could? Or they're also saying, well, doesn't it just work? Can't you just give me the privileges to do this? And what we're also seeing is that there is an awful lot of cost consideration in this. There's an awful lot of security consideration. And what we've built up over the last, I would say, 2 to 3 years are an awful lot of experience and war stories on there are different ways to do this and there are different things to look at. So I think what you're going to see tonight are 3 presentations on some of the specific considerations around empowering developers in the cloud, some war stories, and also some general concepts that you would be good to bear in mind if you ever go on this journey yourself. Or maybe you're already going on it. And if you are, please share some of your questions on Slido for the panel afterwards, because this is all about sharing our experiences and developing our community. Okay. So without further ado, I'd like to hand over to Jamie Kelly. Oh.
Me again.
Sorry.
That's why they sent me.
There you go.
Thank you. So before we do hand over, just a quick word. This community is growing. If you want to become a speaker or you know someone that is a very good speaker that you want to nominate, or just encourage them to get in touch with me, you can email hello@devops-exchange.io and become a speaker or a host for future events. There is an afters bit if you want to collar a speaker one-on-one after this, after we've done the panel. If your question doesn't get answered, for example, from Slido, we are going next door, I'm told this is. There is a tab behind the bar. I know it's a Monday, but it's the Digital City Festival. So if you want to have a drink afterwards and discuss further, that is where we'll be. Make a note of the postcode, but I'm told it's very, very close by. It's literally next door. Okay, great. And that is it. And now, Jamie.
Technical switch over.
Absolutely. Look how smooth it is.
We definitely practiced this before.
Magic wand.
Magic wand, wonderful.
Okay.
I always press the wrong button on these first.
Down.
Yeah. There's my arrow. Oh. They told me before what full screen wasn't it?
See, if we did this in the cloud, it would have been done already. You're fine.
Command F.
Just F.
Just F.
Oh, wonderful. It's worked. Brilliant. So, hi, my name is Jamie Kelly. I also work for BGSS. I work as a lowly platform engineer. I'm not a cloud consultant. That's those 2 jobs. I'm going to talk about DynamoDB pricing models because I thought that would be exciting, sort of. See if I can move that out of the way first because that will really get on the nerves. Wonderful. So quickly before I start, can I just get a quick hands up of everyone who's heard of Dynamo? Has everyone heard of Dynamo? Most people, wonderful. Who's used it, played around with it? Who's got it in production? Wonderful. I can just say pretty much whatever I want. So today I'm going to cover over a little bit of what Dynamo is. Most of you seem to already know about that. Also, green laser. That is awesome. I don't think I've ever had one that's not red. Have a quick talk about what DynamoDB is, and then we'll go through a couple of different pricing models. And then I've actually done some maths. Please don't try and actually see if it works out right. I'm sure it does. Don't prove me wrong. We'll cover that in the examples question, and then there may be a little bit of time for questions at the end, but I think most of it's meant to be saved for the panel discussion at the end. So 15 minutes. The talk is definitely longer than 15 minutes, but I'm sure we'll get through most of it. Of the 57, by the way, in this corner, I don't have 57 slides. It counts 1 per transition. I don't know how I'd be able to get through that otherwise. So DynamoDB, what is it? DynamoDB, so it's a key value and document store. So a lot of people call it a NoSQL database, for example. Generally, you give it a primary key, you get an item back. It's an AWS managed service. So by a managed service in AWS, AWS will provide things like S3 and EC2. These are fairly core infrastructure offerings. DynamoDB is much more of a managed service. You don't have to look after the underlying hardware. You don't do security patching. You don't have to worry about other bits and pieces like scaling it. AWS manages a lot of it for you. You tell it you want a table, tell it a couple of configuration options, they're sorted. Automatically scales. In terms of storage, I'm mostly talking about here, there is some auto scaling in terms of capacity and throughput as well, but mostly I'm talking about you don't have to say it's going to be about 100 gigs worth of data and then have to worry about crap, I'm running out of space, need to make it bigger. It'll just handle as much as you can throw it. If you're actually reaching to the point where you're getting limited on how much you can scale, don't take advice from a 15-minute talk. Can be relatively cheap. I've used 2 words to get out of this, can and relatively. If you're using it in the right way, it can be a lot cheaper than using other ways of storing data, but it's hugely dependent on actually getting it A, set up right, and B, using it correctly. One thing that a lot of people seem to think to begin with was that document stores and key value stores are great. Just chuck whatever you want in them, and then we'll worry about how we get it out later. To actually get the best usage out of things like Dynamo, it's best to know how you're actually going to be accessing that data. And if you can do that, you can get it working very cheap indeed. And it's fast, really fast. Single millisecond latency. That's off of the Amazon webpage. I've not measured it, but I'm going to take their word for it. Seems pretty good. It means you can actually use it as a cache. I've used that in a project before. DynamoDB was used as a cache in front of an SQL database. Very good reason for it. I'm not going to go into the detail. And that's what an item can look like if you get it back. So your primary key would be something like the author and the title combined. So you would have the partition key, it's called, and then the sort key. Composite together, that will give you a primary key that you can use to access some data. You can also just use a partition key. So that's roughly what DynamoDB is, for those of you who aren't entirely sure or needed a refresher, and so that I can remind myself. Next stage, DynamoDB pricing. So there's 2 main ways of doing DynamoDB pricing. And they are the provisioned capacity. So this is where your billing model is that you're basically paying for a set amount of throughput. And you're getting that throughput fairly consistently. You go above that throughput, you're going to start getting throttled on it. The other way of doing it is on demand. On demand, instead of paying for throughput, you're paying basically per request. So you've got a model where you've got provisioned throughput. As long as you don't go above it, you're fine. And on demand, it'll sort all the throughput out for you, more or less. And you pay per request. This bit, right pricing structure, depend on your workload. There's no one is better than the other. There's one that I think everyone should probably be using most of the time, but it depends what you're doing. That's why there are 2 options. If there was one that was always better than the other, they'd only offer one option. Provisioned capacity. So this is the first one we'll have a quick look at, and then we'll have a look at the on-demand. So provision capacity, I'm going to have to look at this to read this one. Provision capacity is a reservation of throughput measured in write capacity units and read capacity units. And soon we're going to get to read request units and write request units, and it's a little bit muddling. But yeah, you're basically, as I say, you're reserving a certain amount of throughput. The capacity units that you set on the table determine the number and the size of requests that you can make before getting throttled. You'll still be able to make as many requests as you want. you'll just get throttled on a load of them. The service won't break. You'll just get a whole load of throttled requests. So what is this write capacity unit? One write capacity unit, one write request up to a kilobyte in size per second. So a few examples, 5 writes, 1 kilobyte per second. It's going to be 5 write capacity units you need. 5 writes of 2 kilobytes, it's going to take 10. And 1 write of 5 per second is going to take 5. Fairly straightforward to work out how to use write capacity once. Then you get to read capacity. It's great. Half a read capacity unit will give you 1 read request up to 4 kilobytes per second. Or, if you're using strongly consistent, so that's for eventually consistent data. So it could be a tiny bit out. I think it's about a second it could be out by. 1 read capacity unit will give you 1 read request up to 4 kilobytes in size per second that's strongly consistent. And then you have the transactional cost, which is double that again if you're making a transactional request. Right. More examples of the read ones. 6 reads of 4 kilobytes, 3 RCUs, that's fairly straightforward. If you're doing 6 reads of 1 kilobyte, it's still going to cost you 3. This is for the eventually consistent ones. And that's because it's still each individual request is going to take up those units. 6 reads of 5, it's going to double it because you're going over that 4 kilobyte limit, and 2 strongly consistent reads, 4 RCUs, and then the transactional one. So that's kind of how they add up. It's per request, and it depends on how big the piece of data is coming back. But to be honest, 4 kilobytes, you can fit a lot of stuff in. On demand is, I was going to say completely different. It's not. It's almost exactly the same. You just kind of miss off the per second bit. So on demand is a pay per request model that's measured in very similar acronyms that are slightly different: write request units and read request units. And I did copy and paste a lot of this, and I'm really hoping that I didn't get the wrong acronym in the wrong place. But we'll see. It'll be fine, I'm sure. There's no capacity to set. So the interesting thing with Dynamo on demand is the capacity of DynamoDB on demand. 2,000 write request units and 6,000 read request units to start with. That's what's called the peak of DynamoDB. And so it can automatically handle from when you provision the table up to double what that peak is. So if you start a brand new on-demand table, it can straight away handle 4,000 write request units and 12,000 read request units. And if you've got something and you know it's going to be taking up a hell of a lot more than that straight away, so 10,000 writes and 20,000 reads, you can actually just preset it on the provisioned capacity to that high, switch it straight over to on-demand, and it will keep that as the previous peak. So this is going to be really familiar. 1 write request unit, 1 write request, 1 kilobyte in size, basically just dropping the per second. Throughput's already worried about. All you're doing is measuring how many reads and writes you've got. So again, for the reads, it's pretty much exactly the same numbers. You're just losing the per second bit because you're paying per request, not paying for throughput. And that is a whole load of stuff to take in without some solid numbers on it. So, having gone through these, exactly the same examples we were seeing before, you're just missing out the per second side, just to give you an idea that the units, whilst not completely interchangeable, you can do the similar sort of maths on them. Examples. Human body. So, I've got 2 examples for you. One is the consistent load, so we're going to actually put some numbers to it so we can see the difference in cost. Consistent load, so we're talking about 4 kilobyte. That was definitely 1 kilobyte. Mustn't have got the updated slide. That's meant to read 1. Ignore the 4, otherwise the maths does go wrong. 1 kilobyte items, 100 writes per second, 8,000 eventually consistent reads per second throughout a month. If you've got this sort of consistent load, this is where the pricing model of provisioning it beforehand is really going to pay off for you. So if you're doing provisioned writes, you're going to take about 400 WCUs plus 10% headroom, so 440. And provisioned reads do the same. Take what you need, add 10% just in case it's a little bit over. So those are the numbers we're going to work off of. On demand, I did do the maths for this, I promise. It's not just made up. 250 million write request units and 10.5 billion read request units. So those are the numbers that are based off of, so AWS, a lot of their documentation over a month, they say, is about 730 hours. So that's how I've done the maths if you do want to try and replicate this. So how much does that actually cost? Because that doesn't really mean anything at all. That's the monthly cost for the provision pricing on that. That's going to cost about $708, about $700. paying for those requests per hour. So you've got that provisioning all across the month. It's going to cost you about 700. If you're paying per request, about 3,000. It's about 4.5 times as expensive. So if you've got a static load and you can consistently say it's always going to be about the same, it makes so much more sense to always just go provisioned. However, if you've got a daily spike, and again, that was meant to say 1. It said 1 about 3 hours ago, I'm sure, maybe. It definitely says it now. If you've got the exact same load, so 100 writes per second and 8,000 eventually consistent reads per second, but you're only doing it for an hour every day, that's a very different workload. And if for the rest of the day it's say 100th of that, so 1 write and 80 reads, then the numbers change fairly dramatically. Not for the provisioned one, because you're still provisioning the same amount to account for that spike, but on the on-demand requests, they drop significantly. So instead of 250 million and the huge 10.5 billion or whatever it was earlier, you're slimming down to under 15 million writes and just over 600 million reads. And that really changes how things are priced up at the end of the month. So provision still costs the same. It's provisioned to be able to take that load. But on-demand drops significantly. So that drops down to $200. So you're now less than a third of what the provision cost is. And that's just for being able to account for that one spike. So in general, use provisioned for predictable workloads without large spikes. This doesn't just have to be a consistent throughout the entire month, you're always hitting it the same. If you've got something that's a bell curve, that will also work because provision does have auto-scaling capabilities. Definitely don't have the time to go into all of that. But basically, if it's consistent and the way where it ramps up and ramps down fits in with the way that Dynamo does auto-scaling, it's always going to be cheaper to use provisioned. But if you do have that kind of bell curve and you've got spikes at certain times in the day, but they're predictable, you're going to have to do a bit of the maths yourself to work out whether it's going to be able to actually ramp up quick enough, because in some cases, DynamoDB won't ramp up quick enough. On demand for anything that's spiky or unpredictable or really low volume workloads as well. Pretty much everything I've actually worked with ends up falling into this. It ends up being cheaper to just go on demand rather than try and work out whether you can have a low enough provision capacity but still be able to account for a spike, or auto scale it, but does it actually happen quicker? A lot of times, just stick it on demand, it's going to be fine. I would say if you're contemplating between the two, unless you know that there's a good chance provisioned is going to save you money because you know you've got a very consistent workload, just go with on demand. You can always change it if you really need to. But more importantly, do the maths. You can work it out. AWS has got the pricing on there. You can work out how big your average item size is, and you have some idea of the request weight. You're going to be able to work out how much it'll cost. And just as a ballpark figure, if you've got 1 write capacity unit and 1 read capacity unit, then that's the equivalent of about 380,000 requests every month. So if your Dynamo table is taking less than that, then it's automatically going to be cheaper to do Dynamo. This is from a live project that I'm working on currently. You can see the dates, February, March. This is just, the day's just gone, that was this year. So I was advising them on how they could potentially save some money on Dynamo. That was all pre-provisioned. 21st, you can see pre-prod went to on-demand halfway through the day. So we've got half the cost provisioned, half on-demand. And then that's where our pre-prod environment was all on-demand, but prod was still all on provisioned. And then, as you can tell, this is where we went straight to on-demand. So for this particular workload, and as I say, it's about 30,000 request units per day were being used, significantly cheaper to go on demand by a huge amount, actually. They were very happy with that, surprisingly. And that's about it. So does anyone have any burning questions before I hand over? Wonderful.
You on the board?
Oh, well,
You don't get away that easy.
oh, no.
Nice try.
Who put about Route 53? Because I love that, whoever did it. Yeah, it is. That's why I love it.
Yeah. Are you going to answer some of those?
I'm sure I'll be able to. Maybe.
Yeah.
Sorry, I have one question, if you don't mind.
Yeah, sure.
So, is it possible to switch between one price and the other?
This question.
How easy is it to switch?
Yeah. Okay. So how is it to switch from provision on demand? Very easy. So you can switch once every 24 hours between the two modes. So you can't just switch to one and then go, oh, no, I need to switch back. quite so easily. It takes a bit of time, so switching between provisioned and on-demand we did recently, as I showed you, it takes an amount of time on the order of like 5 to 15 minutes, or could take a bit longer, I suppose it depends on the table itself. But you flick a couple of options in Terraform or CloudFormation, because you're not going to do it in the console, obviously none of us would do that. And yeah, 10 or 15 minutes later it'll be ready. The important thing actually when you're switching between provisioned and on-demand is that you don't have downtime. It carries on with the previous capacity fine. So if you've got capacity set and provisioned and you switch to on-demand, you're not going to have any downtime, you're not going to lose any traffic over that. It will just gradually switch and then it'll be ready. Does that answer that one?
Take the Route 53?
Yeah, Route 53. Quinny Pig's awesome. Love it. There you go. Route 53 is the best database you can possibly have. There's that one done. Best way to monitor the performance of Dynamo so I can get insight to cost optimize it. Okay, great. So this is if you've already got something running to optimize it, or yeah, so it's monitoring performance. So if you've already got Dynamo running, there are already some metrics that are getting exported to CloudWatch. And if you catch me afterwards, I can probably find you exactly what it was. I wrote a script a while ago. It was about that long on the monitor-ish. And that script would go and find all of the tables that I had, and it would go and get the provisioned capacity for all of those, and it would work out from the pricing of provisioned capacity how much that cost, and then it would also go and get the consumed writes and consumed reads, so those are metrics that are exported as well. And you can take those and work out on the on-demand cost how much it's going to cost you. So I did have a script at one stage to do it. If you follow that sort of recipe, you can print out a little table that says you're spending this much and it would actually cost you far less if you went on demand. Or it'll tell you even far more. Why do I want to use document or key value store like DynamoDB? It depends how long you've got to answer this question.
30 seconds.
30 seconds, right. Okay, so if you know how you're accessing your data and you can build a DynamoDB table in the right way, which isn't as easy as some people think it is, you can have a super cheap, super reliable database, and that's why I've generally used it. So we've got, I've had live loads running through DynamoDB on projects that are running now that are costing less than $1 per day. So the cost savings are immense, and you don't have to worry about managing it. But that's a much deeper question. So whoever asked that, if you want to catch up with us afterwards, depends which side you're attacking it from, really.
Plug into that. All good. Okay. So Slido continues, so keep asking questions on there and give them thumbs up if you like. Over to you. Thanks, Rob. Thank you.
Right, okay. So one of the questions that has now unhelpfully disappeared from the screen was about how often people are deploying. And I think can we get that back? I can get that back. Just to put you under pressure. Wow. Or do you have to make...
I just need to get my mouse on that screen. There you go.
Cool, okay. So I think one of the interesting things to me with this, and this kind of leads into quite well into my talk, most of the answers here are monthly and weekly. So, in terms of talking about, businesses being able to add new features, release software updates and things like that, being able to, or deploying into production monthly and weekly. So let's say sort of weekly is kind of, you've got weekly, less than 6 months, everything like that. A lot of what we do, so as an AWS consultancy, is about working with businesses to try and accelerate their software delivery. So if you're deploying monthly, realistically you're doing one big deployment every month. That tends to come with its own risks and things like that, which obviously I'll go through now. But I think what was interesting for me is just how many, obviously I don't know, is that 25 people that have answered? Yeah. So near enough, well over 50% of 25 people are deploying less than weekly. So kind of an interesting statistic. Has anyone heard of the Phoenix Project DevOps book? Cool, that was a lot more nods than I was expecting, actually. So, yeah. So I won't go into too much about this, but what's particularly interesting and sort of one of the main takeaways from that book is, for me, is this single sentence. So basically, most of the work that businesses are doing, unless it's actually delivering features to a live production product, is not really adding any value to the business. And one of the key things about the Phoenix project as a whole was just how much time was being wasted on internal IT projects, on rework, basically. So that was one of the key words that was talked about a lot in the DevOps project, was rework, which is basically deploying stuff into production manually, things breaking, and then developers having to spend a lot of time instead of instead of deploying new features, having to fix production systems. So as an AWS consultancy and as a DevOps consultancy, we spend a lot of time going into lots of different businesses, and generally the talks that I would give and do give tend to be more sort of technically focused, and I want to try something a little bit different this time, where kind of talking about what, not necessarily what we do as a business, but what the kind of things that myself and other consultants that work at Steamhouse have kind of come across when we've been working with other businesses, the types of things that we recommend that companies do, and basically how we take a business that are deploying monthly and get them to a point where they're doing many, many deployments a day. This is probably a fairly familiar wheel. Like, I'm not claiming that we've developed this. We have nicked it with our branding, but that's about as far as it goes. So this is the DevOps feedback loop. So again, this was in the Phoenix project. It's a pretty standard DevOps thing. How many people, out of interest, would say that they are doing absolutely everything on this wheel? So all of the way around to having monitoring metrics and stuff feeding back into like application planning and feature development and stuff like that. A couple? Some very sort of gingerly hands going up there. Cool. Okay. So this is kind of what we use to measure how mature like a DevOps implementation, a DevOps philosophy is within a particular business, and we kind of do that based on three things. So one is culture. We're not a company that goes in and talks about how to do DevOps culture. We are an AWS consultancy, so we talk purely about tooling. The other one is tooling. So basically, are you using public cloud? What services are you using on public cloud? How are you using them? And then the third one is processes. So where we kind of sit is purely on tooling and purely on infrastructure. And that's kind of what this talk's meant is kind of focused on today. So one of the big things that we go in and do is implement continuous delivery. And that can kind of mean a couple of different things for different businesses. And these are kind of the three main, the three main milestones, if you like, in terms of going into a business and getting to a point where they're doing continuous delivery. So most companies that, I'm not actually sure how to make the pointer work. Oh, there we go. Most of the companies that we work with are at the continuous integration phase. So they are writing application code, committing it, and then they have an automated test suite that runs against it, and that kind of tells them whether or not it can be deployed into production. When they actually do that deployment is generally manual. It's some guy at a desk writing some code, running some scripts that maybe they've potentially written themselves, or in a lot of cases it's actually going onto servers and copying code and stuff like that. So there's, just because the code has passed, so developer says, okay, my code's fine, usually what ends up happening at that point is development and deployment issues will happen when they actually try and get that code into production. Continuous delivery is kind of where we want to try and get businesses to, and I think generally where most businesses should be now if they're at a point where they're wanting to kind of, sort of take over from competitors, if you like. So it's all about bringing stuff to market quickly. The quickest way you can do that is by automating, ultimately. So continuous delivery is about taking the application code that has been that has been committed by developers and has passed tests, and getting that automatically into a testing environment. The main thing about getting it into a testing environment is purely the fact that once it's in there, it's there for the business to look at, it's there for the business to approve, it's there for it to be signed off, and there for it to get deployed into production. And there's kind of two different ways of doing that. So there's continuous delivery, continuous deployment. Continuous deployment is what the likes of Facebook and Netflix and companies of that size will talk about, where they're writing code, it's automatically getting deployed into production. Most businesses don't need to be doing that. And actually, the amount of technical infrastructure that has to be implemented to get you to that point is probably not worth it for the majority of businesses. What we do instead is continuous delivery. Ultimately, the only difference between the two is that there is a manual approval phase. So basically this thing here. And the key thing with this is it does not need to be a technical person. So it can be a product owner, or it can be a business leader that can make the decision when a piece of code has been committed, has gone through this phase and has passed the tests. It's in the staging environment. This person here does not need to be a person sat at a desk, a technical person that approves that deploy. So all they're doing is pressing the button saying, deploy this into production, and that is an automated process. And then from that, you've got rollback as well. So what are the benefits of continuous delivery? Automated software releases. So basically, anything that you automate, it's about taking work away from developers. So developers can focus on actually adding value to business, can focus on adding new features rather than, again, going back to the Phoenix project, what they talk about is rework, spending all of their time having to fix production issues and stuff like that. So automating that problem away. Improved developer productivity, improved code quality. So by having a pipeline where you have multiple deployments a day, and you're constantly testing that deployment process, you're splitting the actual amount of work being done, so the actual code that's getting committed each week. And by doing so, you're pushing more and more features out more frequently. And the most important one for me is lower lead times. So this is actually from quite an old DevOps survey. I think it was like the 2017 one. So 440 times faster lead time from commit to deploy. And that's purely from having that automation and purely from doing continuous deployments all the time. So obviously we're an AWS consultancy. We purely use AWS. There are other cloud platforms. I'm not saying that one is better than the other. So all of these apply to cloud in general. There is no right cloud platform. Although if Amazon are here, then it's AWS. So why use AWS for continuous delivery? Why use cloud for continuous delivery? Main thing for me is fully managed services. So in traditional infrastructure, developers and engineers are spending a lot of time maintaining systems that they now don't need to. So the likes of AWS give you fully managed services. So whether that's container services, whether it's big data, whether it's databases, they're managing all of that for you. They're taking the responsibility away. You build services with them, and they do the management. They do it automated. Realistically, they're much better at looking after managed services than I am, than most people are. They do it at scale. Let them do it. Let them, pay them that bit extra. Let them do it. They're built for scale. Managing a single instance on Amazon is pretty much the same as managing 10,000 instances if you're doing it in the right way. There are other benefits here, so pay-as-you-go and stuff, and cost is not really the biggest thing when you're looking at moving to cloud. It is something to consider, but realistically, most of the other benefits generally outweigh cost. The main two things for me, it's API-driven. So all of the infrastructure can be provisioned through APIs, and it can be automated. So using Amazon's tooling, you can automate, or any other cloud platform's tooling, you can automate all of the infrastructure that you want to. You can automate all of the continuous integration, continuous delivery, all of the cloud platforms provide all of this stuff natively. We're not at a point anymore where we need to reinvent the wheel. There was a time where lots of different companies were all building their own orchestration, their own config management. These are all solved problems that we don't need to worry about anymore. So use what the cloud services are providing. We are a consulting partner, so I have to say the bit about also using the partner ecosystem. This is not just about consulting partners like us. There is a whole marketplace of cloud products that are available, whether that's monitoring, whether that's data solutions, that can solve a number of different problems that businesses face. And that can help you adopt continuous delivery. So the key thing for this talk is how do you adopt continuous delivery with AWS? So again, you can adopt it with other cloud platforms. I'm going to talk about some of the tooling that Amazon gives you. So again, this is about using the services that Amazon provides, so not bringing third-party open source tooling or anything like that. You can do that, there's nothing wrong with doing that. This is purely about what Amazon provides out of the box that you can use on a pay-as-you-go basis, and some of this is actually free, to get to a continuous delivery pipeline. And this is also what we use when we go into businesses and what types of software that we bring to businesses. So the first thing is infrastructure automation. How many people are orchestrating infrastructure, so using a tool like Terraform, using a tool like CloudFormation? About half? Okay. So basically, orchestrate absolutely everything. Do not provision stuff manually on AWS. The second you provision stuff manually, it is already tech debt. It is just as simple now to orchestrate stuff using one of the orchestration tools that the cloud platforms provide. So with Amazon, you've got CloudFormation. You've also got the Cloud Developer Kit, which is a relatively new one. So that's more towards sort of developers than it is potentially towards sort of ops people. You've also got Terraform. If you're like me and you hate writing stuff in YAML, Terraform is a great tool to be working with. One advantage with Terraform is it's also multi-cloud. So you can manage cloud infrastructure. You can also manage external resources as well. Packaging applications. So using something like Docker. I'm a big fan of Docker. I'm a big fan of containers in general, because they allow us to package up application code, separate application config, and basically ensure that the exact same code that works on my laptop works on AWS, works on Google Cloud, so on and so forth. And the key thing for me is about automated deployments. So using the same deployment process for your infrastructure as for your application code. So when we talk about AWS's CI tools, so you've got code pipeline, you've got code build, and code deploy. So code pipeline is, anyone use Jenkins or a tool like that to sort of do CI jobs? Yeah, I think it would be quite a few. So code pipeline is basically Jenkins on AWS. Code build is there for, so basically code pipeline is the tool that manages the sort of overflow, the overarching process of a CI job. Code build is the thing that actually builds containers or compiles libraries and things like that. So it's providing you with compute to do some compilation. And then code deploy is the continuous delivery tool. So who's using Jenkins for actually doing deployments out of interest? Okay. So Jenkins is not a deployment tool. So this is what I find particularly interesting. So Jenkins was originally designed for testing of code, and then basically because it provides a nice sort of pipeline tool, it's now used for deployments. The one problem that you'll have with a tool like Jenkins is the second something breaks, and the second a deployment fails, the rollback is then a manual process, because usually you're kind of writing like CLI tools and stuff like that. So AWS provides you with code deploy. That is a continuous delivery tool. It integrates with AWS. If a deployment fails, it rolls back itself. And it can also do some other stuff, which I'll get into in a minute. And then the other one is role-based access control. all of AWS provides access control to every single service, so I'm sure plenty of people have heard of IAM. So being able to control who can do deployments, because you're using AWS native tools, you can say, X user is allowed to do deployments, and you can go down to quite a granular level. You can restrict by days of the week, so you can only do deployments during the weekdays. You might not want to do deployments on a Friday, for example. And there's plenty of stuff like that where you can start to combine AWS services. And then a couple of tips for continuous delivery in general. So trunk-based development. This is more kind of a personal preference. I'm not a big fan of using branches in version control. One of the problems with branches in version control is they kind of accumulate tech debt quite quickly. So anyone that's running a sort of branch-based version control, I'd imagine you've got quite a lot of branches, and you don't necessarily know if all of them are active, maintain the latest code and stuff like that. Branches don't tend to work particularly well with continuous delivery either. One of the main things with continuous delivery is about having a single code base that can always go into production. So having a very short running branches is fine. So when you start writing a new feature, having that in a short running branch is fine, but get that merged in at the minimum at the end of the day, ideally sort of many times a day. And when you're merging into that trunk branch, it's about it being ready to get deployed into production. A couple of other things. So all of the CI pipelines can be orchestrated using all of the same orchestration tools that I talked about on the previous slide. One of the key things for me as well with Code Deploy is it gives you canary deployments. So canary deployments is basically deploying a new version of the application and sending a percentage of traffic to it. There are other deployment methods, so you can do blue-green and stuff like that, but ultimately canary deployments is the one where you can deploy new features and send a percentage of traffic to it, see how that works over time, and then gradually kind of roll that new feature out. When I get onto monitoring in a sec, we'll kind of see how those two things tie together. And then kind of finally, from a continuous delivery point of view, it's about integrating security earlier into the pipelines. So before code gets deployed into production, it should have already gone through security review. There should be stuff in the pipeline that's doing things like static code analysis. There are open source projects that can do this now. Amazon also does container scanning now, which is a relatively new feature. So again, it's just about checking code from a security point of view before it goes into production and trying to solve and get ahead of some of those issues that have historically come up and been an ops problem. So it's kind of shifting security left a little bit. And finally, this is kind of the one thing that we find that most businesses aren't doing. I'm not saying that businesses aren't monitoring, but they're not feeding the monitoring data back into the kind of development pipeline and into planning. So one of the key things for me is making software delivery metrics visible to the business. A couple of the key sort of metrics that we track is the average time a change takes to reach production, the number of deploys that we're doing per day, or that a business is doing per day, and the most important one for me is what that change failure rate is. So change failure rate is when a deployment is automatically rolled back, and I'll get onto that in a minute. But these are important metrics to kind of bubble up to a business level and make those kind of visible. So the other aspect is visualizing deployments. So most businesses will have dashboards showing how the infrastructure is performing, sort of what the latency of the application is and stuff like that. This is about overlaying deployment events on top of those graphs. So showing when a new feature actually went live in production so that you can kind of see, if there's a drop or a spike in a graph, actually a deployment was done 5 minutes before that. Maybe those two things are related. Let's get that feature rolled back and do some more investigations in a UAT environment. And kind of automating that process as well. So automated rollbacks. So one of the things that CloudWatch gives you now, particularly with AWS Code Deploy, is being able to automatically roll back a failed deployment based on CloudWatch monitoring metrics. So these can be custom metrics or they can be built-in metrics. So some of the ones that we use fairly regularly are latency. So if the application has specifically slowed down quite a bit after we've done a deployment, that's usually a bad sign. The other big one is error rates. So if the number of 500 errors, for example, has skyrocketed since a deployment, generally it's better to roll back than try and forward fix. So, and then the final one, so AWS's new tool, AWS X-Ray, is an application performance monitoring tool. So if you've heard of sort of New Relic and stuff like that, kind of similar, but based on a sort of more sort of microservices and serverless architecture. So what X-Ray allows you to do is plug in their agent throughout your application. So not just monitoring database transactions and things like that, but also monitoring user behavior. When a user's running a request, what their latency is like, and this kind of gives you the ability to track an entire user's request all the way from their browser and their network, all the way through their application stack. And that tool becomes particularly important when you start to do things around microservices, where you're running lots of services that are kind of communicating between each other and stuff like that. It's very easy to end up in a situation where you've got lots of microservices and it's very difficult to then track where requests go. Kind of conscious that I've waffled on a bit longer than I intended to, so thank you.
We'll just do a couple of questions, and then we'll do next speaker. We'll have a break, get some more beer, a drink, and then we'll come back and finish off the rest of the questions after that. Okay. Yes, the top question there, do you see cloud native services maturing to the point where tools like Jenkins are no longer required for CI/CD?
So yes. So I'm not a particularly big fan of Jenkins in general. You probably got that from the tone originally anyway. I guess it depends what that question means in terms of whether CI tools are not needed anymore or whether it's just specific to Jenkins. If it's just specific to Jenkins, then there are already AWS tools that I would say do a much better job than what Jenkins does currently. Like I said before, there are lots of companies that are reliant on Jenkins doing a lot for their business. AWS tools can do that. Other cloud tools can do that without having to manage what is now quite an archaic deployment tool.
We'll just do one more and then we'll...
How difficult is it to move from monthly deployments to daily? So, I mean, assuming that you're able to do quite a lot of the things that I talked about on that talk, it's relatively easy, but it's about having the company's buy-in in general. So there is a lot of work to do to get particularly from a confidence point of view. So having all of that automated deployment tooling, trusting the tooling, that's the main thing that we tend to struggle with when we go and work with customers, is actually getting them to the point where the tooling's there, the tooling works, but they still only want to do one deploy a day. They still only want to do one deploy a week or something like that. And it almost becomes like this thing that they build up to at the end of the week, as opposed to just a daily, many times a day kind of task.
All right, we'll leave it there. Thank you very much. And we'll sorry, okay, and then we'll next speak, and then we'll come back and finish the questions off after we have a break. Ready? Thanks very much.
I don't know. I don't know where it's gone. There we go.
No worries.
Down.
Next one.
Okay. I'll see if I can remember down. Hello. You doing all right? Not bored yet?
Hello, Joe. No, I'm joking. I'm not going to sit here, don't worry.
Maybe another day. Maybe another time. So, well, there might be the odd visual gag in here. So let's see how we go. Right. So, hello. I'm James Young. I'm a cloud consultant at BGSS. What do I do? I don't know, but it's to do with clouds and consulting. So it's kind of fun. So I'm going to do a talk to you today, which I've called A Partridge in a Pear Tree, or a cautionary tale of CV-driven development. I'm sure it'll all make a bit more sense once we've gone through this. So who's familiar with the concept of CV-driven development? Oh, quite a few. Okay, interesting. Right, well, let's get straight on to it. Obligatory disclaimer. This is all fictional. Some of you may know the great author Kurt Vonnegut. This is one of his phrases slightly abused, so apologies to him. So, are you sitting comfortably? I'm going to tell you a story. Once upon a time, there was an app. It really doesn't look very comfy, does it? It was a fairly simple CRUD app. You all know what a CRUD app is. Well, some of you probably. Create, read, update, delete. Okay. Web app with a small bit of number crunching on the data. It's pretty simple. The client wanted it in C# because it was the only language they'd ever heard of. You've probably met people like this. You've probably worked for companies like that. And in the same way, they wanted it on Azure because it's the only cloud, right? It's the only one they've heard of. So the original developers, being the forward kind of thinking developers they wrote it in .NET Core because portability is good. Am I right? Yeah? Hands up who likes portability. Okay, some people. All right. Fair enough. It's really good. You don't have to run it on Windows. That's a bonus for everyone. Also, they decided, we're going to do a set of microservices because that's definitely the right solution for all applications under all circumstances, right? Yeah. The app, it needed to store some data. So the developers started out with, I'm calling it Squeal today, because that's what you do. It's what you do in applications. You need to store some data. You think, I'll have a SQL database. Sorry, a Squeal database. Then they decided they needed an ORM, an object relational mapper. Everybody knows what one of them is? If you don't, you're soon going to if you're working in this field for a bit. Anyway, who wants to write SQL? SQLs, you do?
I love it. It's great.
You're weird. Anyway, SQL is icky and weird. Objects, apparently, are easy. I'm not sure how that works, but there you go. No one wanted to do it properly, though, because who wants to do things properly when you've got features to write and the client's banging on your door going like, where's my feature? Come on, where's my feature? It's like a drug dealer. Like, where's my money? Come on, where's my money? Where's my feature? You ever get that? No? Yeah? Okay. So they decided to not bother doing schema management because who needs schema management in development environments, eh? You just remember what's changed in the database this release. It's easy. Easy. Then someone decided, well, actually what we want is some JSON documents in there. And if we did everything as JSON documents, then actually we could do away with the SQL databases, and that doesn't need schema management either. So kills two birds with one stone. Oh, I was supposed to not talk about killing animals today, and that was a very bad thing. Sorry. Bad turn of phrase. No one told them, though, that actually modern SQL systems have a JSON data type, which works pretty much just as well as any other way of storing JSON documents. But, SQL's boring and old, and it's not web scale. Whatever that means. And who cares? Because we're delivering features. The client loves us. We're delivering features now. So, whatever.
So they decided they needed MongoDB. I'm just going to pause here and have a moment for Max von Sydow, who this isn't, but this is a cosplayer who is pretending to be Max von Sydow, being Ming the Merciless. Max von Sydow, rather, unfortunately died today after I had written these slides. He was at the ripe age of 90. But for those of you who are fans of Flash Gordon, unfortunately Ming is dead. Sorry. Anyway, so they decided they needed MongoDB. Then they realized running MongoDB is a pain. Who's actually run MongoDB themselves for a bit? Did you enjoy it? No, exactly. But they'd already written the code, and because they're delivering features now, they can't really go back on that, can they? So then someone thought, oh, we're on Azure. Really brilliant idea. Let's use Cosmos DB. That can pretend to be MongoDB. It's got a MongoDB compatible API. And it's an off-the-peg Azure service. It must be better. Surely it must be better. So they started to use Cosmos DB, and no one thought anything more of it until they got the bill. Pathetic earthlings. I was thinking he kind of represents Cosmos DB because he's a cosplayer. He's pretending to be Ming. Sorry. Then someone thought, why not use some containers? I mean, we're deploying microservices, the perfect fit. Everyone loves containers, don't they? I think we've just had a presentation which was all about how much we love containers. So they experimented with Kubernetes. A cluster was built and some Linux containers, and because they'd been forward-thinking and written it in .NET Core, they could do it on Linux. Awesome! Portability is important, right? But then the client decided that's not what they wanted to do because it's all very faddy technology. We don't want fads in our stack. We want to use this for the next 20 years. And Kubernetes is Linux, right? They don't want Linux. You can't have Linux. Linux is a fad. Is it? And Kubernetes, well, that's definitely a fad. Everybody knows that. I probably don't need to mention that they were a Microsoft shop. So it was being deployed on Azure. So they thought, I know, let's use Service Fabric rather than Kubernetes. Who's heard of Service Fabric? Okay, a few people. It's kind of Microsoft's alternative to Kubernetes. I don't like it much, but some people might do. So how about we deploy using that instead of Kubernetes? I mean, it runs pretty much the entire of Azure. It's what Service Fabric was written for. It's running Azure. Almost all of the services that underpin Azure are run using Service Fabric underneath. And you can kind of tell it's an internal Microsoft tool. It's kind of a bit rough around the edges. But anyway, surely if it underpins Azure, that can't be faddy, can it? So the container tooling was ported to Service Fabric, because one of the things Service Fabric can do is it can run containers for you, like Kubernetes, in a cluster and make sure they're reliable. Then someone went, oh, actually, yeah, we're writing this in .NET, so we don't actually need containers because Service Fabric can deploy .NET applications onto Windows clusters, and Linux clusters actually as well, without using containers. You just give it a zip file, and everything else is assumed to be there. Your container is the .NET runtime, effectively. And so they did that. And then a couple of developers really liked Service Fabric so much, they then went and rewrote big parts of the code to be Service Fabric native. Because, I mean, portability actually doesn't matter really in the end, does it? Who cares? Then those developers left because once they'd played with a faddy bit of technology like Service Fabric and had Service Fabric reliable services on their CV, well, they could get more money elsewhere. So they did that pretty much straight away. And now no one knew how to run or make any improvements or any changes to any of the Service Fabric services. Bad place to be. Then someone noticed that Service Fabric's actually really annoying to run. It's kind of fiddly, it's messy, it's got lots of rough edges. Microsoft expects that you are Microsoft site reliability engineering team running it, really. That's who it's aimed at. So if you, a handful of people, are running it, it's a real pain. So everyone went, oh, I know, let's just port it all onto their PaaS, Azure's PaaS services, onto app services and function apps and so forth. But they couldn't do all of them because actually sometimes PaaS services can't do everything. And in this case, some of them were too big and complicated to run in an app service, or they needed libraries that didn't work properly in an app service because there are some limitations. And then the microservices were ported kind of randomly. So some of the things that would have worked as function apps, yeah, they didn't get ported to function apps, they got ported to app services. The big difference is, well, I'll explain later. But one is kind of functions as a service, kind of, almost. And one is kind of basically an IIS website. Pretty dull. So some of the services remained as Service Fabric services. Some of them were now on standalone VMs. And others were on platform as a service, so on app services and function apps. Kind of turned into a bit of a mess. Oh, no, that's the right one. Yawn, yawn, yawn. This, by the way, is my cat. This is Willow. She's very lovely. But she got very bored with all of the mistakes these developers were making, so she yawned for us. Time passed. The talk's supposed to be short and snappy, unlike the development of this very, very imaginary app. So, in conclusion, through a series of seemingly small and obvious sprint-by-sprint changes, so little things that made sense every time you did them, a really simple web app that fundamentally you could probably run, not in production obviously, but in a development environment as a single VM, ended up with 12 microservices, 11 Azure storage accounts, 10 ways to define a DB connection string, 9 manual steps in deployment, 8 deployment environments, 7 load balancers, 6 Service Fabric services, 5 databases, 4 VM scale sets, 3 QA mechanisms, 2 types of PaaS, and a partridge in a pear tree. No one wants to sing that, do they? Not today. Maybe another time. So, this is the important bit. The moral of the story. Public cloud providers give you access to loads of services that would be completely prohibitive implementing yourself. Things that you don't have the scale to do, you don't have the personnel to do. And it's really tempting and very, very easy to start using these services without really thinking about them, or because you're up against it at the end of a sprint and you can't make it work, or you can't think how you're going to make a feature work, and then there's a service which says, oh, we'll just do that for you. It's really tempting to use them. And in isolation, each of those decisions, each of those little bits of additional tooling, additional services, they make perfect sense. I mean, you know, they mean that you can hit your sprint goals, right? You can deliver what you've said you're going to do. But the problem comes when you've got 25 of those in a row, over and over again. Sprint, every sprint you add a new service because there's something you're trying to achieve which you're finding a bit difficult to do. So easy, such an easy trap to fall into. And it is a trap. You've got to be careful. Bit of a controversial statement here. I know people have already disagreed with me on this, but the complexity of a system is directly related to the number of components within the system. That's basic systems engineering. The more services you add, the more complex your environment is, the more complex your system is, the harder it is to debug, the harder it is to use, the more likely it is to break, the more brittle it is. And not to put too fine a point on it, cloud services are expensive. They promise to be cheap, but in a lot of cases, if you don't use them right, and if you're adding services one by one at the end of a sprint because you are desperate to get a feature over the line, then you will not make them cheap. They will be very expensive. Beware of CV-driven development. Everybody loves playing with new toys, and everybody loves to think about what their next job will be or what fun they might have in another environment. But software projects can suffer, and regularly do suffer really badly, from people playing with too many new toys. You've got to be careful. Be firm. If you're in the position where you are in charge of a cloud environment, don't hand out admin access to your development environments, because if you do that, then it's inevitable, however much you drill developers not to do it, that they will end up going, oh, I'll just add another service. I'll just click on here. I'll just do this little manual change. Automate and pipeline your environments from sprint 0. Really important. Your infrastructure code has to evolve along with everything else. But let anyone raise pull requests, merge requests, depending on which Git server you're using, in your infrastructure code. That's super important, because developers need to be able to make the changes that they need to make, but they need to do it in a controlled way. They need to do it in a way that you can see, that you can understand, and in fact that the whole project can see and understand. And the easy way to do that is to make it code just the same as the application code that they're delivering. Make changes solely through infrastructure as code and pipeline automation. So whether you're using Jenkins or not, or whether you're using something else, it doesn't really matter in the grand scheme of things. Use what's right for you, but always do it as part of the pipeline, and always do it with infrastructure as code. And again, it doesn't matter really whether it's CloudFormation or ARM templates on Azure or Terraform or CDK or Pulumi or whatever you choose. Make sure you're doing it as code. Super important, write your non-functional requirements down early and get everybody involved in them, because if you don't do that, then you won't understand what you can and can't do in your environment. Architectural governance, super important. My recommendation is, if someone wants to implement something new, some new cloud service in your environment, sleep on it for a sprint. Just say, whoa, do you really need that right now? Or can we leave that until later? And 9 times out of 10, if you say, we're going to sleep on it until the sprint after, they'll go, oh yeah, I didn't really need that. Treat adding new services as technical debt, because in many ways they are. If you're going to replace a service, make sure you complete the task, because if you don't, you go from 1 problem to 3 in one fell swoop. And that massively increases your technical debt. There is no such thing as a temporary solution. There really isn't. Anything you do will go into production. If there are any exceptions, well, I'm not sure I've actually ever encountered any. In 20 years in IT, that I've never seen a temporary solution that didn't end up going into production. Same with proofs of concept. Above all, say no. Be prepared to say no. You have to make sure that the environment is fit for purpose, that the services you're using are fit for purpose, and not just sprawl that's accumulated over time. So be prepared to say no. But at